Let's proceed with our next problem on free vibration response. So hinahinay no from problem with a lateral with the stiffness, consideration of the stiffness, and then consideration of the deflection and the damping. Now we have a graph. Now this is a graph where the x-axis is the time, and then the y-coordinate or the y-axis shows us the displacement in centimeters. So we have here a displacement in centimeters. So last time, no, this is u of t. And then here we have time t in seconds. So if you notice, no, there is an oscillation, and then eventually nakagamay ang ato ang amplitude. So again, no, ang amplitude is this one. This is our amplitude. This is row 1, this is row 2. Okay. So the displacement of a vibrating spring mass damper system is recorded on an XY pattern and reproduced as shown. So muna siya. The Y coordinate is the displacement in centimeters and the X coordinate is time in seconds. So we have three problems here. Determine if the system is underdamped, critically damped, or overdamped. Next is determine the natural frequency of the system, C omega, and the ratio of the undamped and damped natural frequency of the system. So, si undamped natural frequency and then the damped natural frequency. So, saan man nato? If you notice, no, the highest amplitude here and then the next amplitude is na coordinates. Di lang kayo siya maklaro. This one is 0.875, 0.75. And then here, we have 4.875 and 0.22. Since this is a coordinating system, of course, this is the x. This is the x coordinate. And then we have here the y coordinate. X and the y coordinate. So this is the time. And then this is the displacement. Yeah, let's proceed with our discussion on this one. So on this one, no natay new concept na introduce which you should take note because this is very important. So we have the first concept here, additional discussion is that the ratio of any two successive peaks. So we have here the ratio of any two successive peaks is equal to like this. So we have ui over ui plus 1 is equal to e to the negative 2 pi the damping ratio times the natural frequency over the damped natural frequency. So sa meaning ui, this is the amplitude here. For instance, this is our ui, and then this is our ui plus 1. Or let's say this is, if this is u1, therefore our ui plus 1 will be, this is our u2. So man siya ang ratio of any two successive peaks is equal to the exponential of e to the negative 2 pi times the damping ratio times the natural frequency over the damped frequency. Another equation or concept that we're going to introduce here, we have what we call the logarithmic decrement. So, ang symbol ni logarithmic decrement mo is delta. So, this is not to be with malibugan with the displacement. So, the logarithmic decrement, actually, Kung namoy graph, and then we have a damp oscillating system, and then what nakabalo sa damping? No, we don't know the damping coefficient of the system. So sa pamaagi para makuha nato si damping is by using the logarithmic decrement. The logarithmic decrement is just the natural logarithm of what? Of ui over ui plus 1. So ano siya? So this is the ratio of any two successive peaks. Take note of two successive peaks. And then if you take the logarithm of this ratio, you will have your logarithmic decrement. Now the logarithmic decrement delta, which is equal to the natural logarithm of the ui over ui plus 1, is equal to 2 pi times the damping ratio is the natural frequency over the damp natural frequency. So pareha ra na siya diri oh. Di ano lang gikuan lang logarithm. Now, since si omega ug si omega d is very close ra man kaayo na siya, this is somehow approximately equal to 1. Kaya yung result mo gito ni, pwede siya 0.98997 or something. So approximately that is just equal to 1. So we can write that the logarithmic decrement delta is, no, not really equal, but approximately equal to 2 pi times the damping ratio. Now, diba, if you remember, the damping ratio is the C, the damping coefficient over 2m omega. Now, how about this one? Graph naman ang nasa 2. We don't have the damping coefficient. We don't have the what else? We don't have the mass here, and also the natural frequency. What do? We have a damping ratio from the in terms of the logarithmic decrement, that is equal to delta over square root of 4 pi squared plus delta squared. And then makuha na ninyo si damping ratio from that one. Okay, so let's proceed. So I'll just write the logarithmic decrement. This is equal to natural logarithm of ui over ui plus 1, or equal to 2 pi times the damping coefficient omega over omega d. And then your damping ratio is equal to the logarithmic decrement over square root of 4 pi squared plus omega delta squared. So naman. So from here, we have two successive peaks, no? This is given by 0.75 centimeters and 0.22 centimeters. So our logarithmic decrement is equal to the natural logarithm of 0.75 over 0.22. So this is our u sub 1. This is our u sub 2. Our logarithmic decrement is just equal to how much? Approximately 1.23. Next, let's say buhato na to. We find the damping ratio. The damping ratio is equal to the logarithmic decrement over square root of 4 pi squared plus delta squared. So we will have 1.23 over square root of 4 pi squared plus 1.23 squared. So we will have our damping ratio, which is equal to 0.192. Pagkakuha pala nato ni damping ratio, and then pagtanaw nato that this is less than 1, therefore the system is underdamped. From this one, makuha na nato si damping ratio by the logarithmic decrement. So, na natin answer si ni A. Next, determine the natural frequency of the system. Okay, dali na lang din kaayo. Okay, we know that the damping ratio is equal to the damping coefficient over 2 omega. But actually, this one, we cannot use this one. So, may next na to buhaton, we need to get the damp period. So, damp period is just the difference of these two peaks. This is our damp period. It shows one cycle. So, our damp period is just equal to the time here minus the time here. So, that is 4.875 seconds minus 0.875 seconds. Sa ito pa, our damp period is 4 seconds to complete a cycle. Since we have our damp period, TD, then we can get our damp natural frequency. So my formula, that is equal to 2 pi over T. So we have 2 pi over 4 seconds. Then we have pi over 2 seconds or 1.57 radians per seconds. So we have our answer for B. The natural frequency of the system. Damp, but damp. This is the natural frequency of the system, but damp. And for C, the ratio of the undamp to the damp. So determine the ratio. So unsa man ang ratio? If you remember, diba, that the natural frequency of the damp natural frequency is equal to the natural frequency and damp natural frequency square root of 1 minus the damping ratio squared. Since you're asked to find this one, automatic na diretso. From this formula, we have the undamped natural frequency over the damped natural frequency is just equal to square root of 1 minus damping ratio squared. So we just substitute the damping ratio. 1 minus 0. How much is that? 192 squared. And then we will have that the ratio the ratio of the undamped natural frequency with the damped natural frequency is just equal to 1.60 radians. No. Sorry. The ratio is just equal to 1.019. So ato to try no pila si undamped natural frequency. So we have damped natural frequency over square root of 1. Actually, we can get that the undamped natural frequency is equal to 1.60 radians per seconds. So, kung tanaw no, doon lang yung sila. See, we have the damp at 1.57 and we have the undamped at 1.6. So, tungod silang kadool no, if we try to get the ratio of the natural over, the ratio of the damp over the undamped, almost agad siya sa 1. That's why kato ang natural or logarithmic decrement earlier, ato siya gi-try as approximately equal to 2 pi times the damping ratio.